Let's learn about chemical bonds. Science, ages 12 to 14. This book explores the different types of chemical bonds in a simple, concise manner. It provides an overview of how each type of chemical bond is formed. This book is geared towards students interested in learning about science. Author, Albert Liu. Illustrator, Albert Liu. Designer, Albert Liu. Chemical bonds can be seen everywhere. Chemical bonds are essential in everyday life. They help join atoms or molecules together, giving everyday objects their unique properties. For example, the chemical bonds in water help make it a liquid, making it available for humans to consume. Electronegativity. Electronegativity is the attraction of a particular atom for electrons. The more electronegative an atom is, the stronger it pulls electrons towards itself. The less electronegative an atom is, the weaker it pulls electrons towards itself. The electronegativity of an atom plays a role in what type of bond is formed. Atoms that have missing electrons in their outer electron shell, their valence shell, need to find a way to complete that valence shell. This is where chemical bonds come into play. Covalent bonds. A covalent bond is formed when two atoms share a pair of valence electrons. Each atom that doesn't have a full valence shell has a bonding capacity, which usually equals the number of unpaired electrons needed to complete the atom's valence shell. The two types of covalent bonds are nonpolar covalent bonds and polar covalent bonds. The polarity of the covalent bond depends on the electronegativity difference between the atoms. Nonpolar covalent bonds. A nonpolar covalent bond is formed between two atoms that have similar electronegativity. The electrons are shared equally if the two atoms have the same electronegativity, such as if they are the same atom, or almost equally when the electronegativity differs by a small amount. Polar covalent bonds. A polar covalent bond is formed when one atom is more electronegative than the other, but not electronegative enough to completely steal the electron. The electrons between the two atoms in a polar covalent bond are not shared equally. An example of a polar covalent bond can be seen in water, H2O. The very electronegative oxygen shares an electron pair with each hydrogen atom, but the electrons spend more time near the oxygen nucleus than they do near the nucleus of each hydrogen. The hydrogen has a partial positive charge, and the oxygen has a partial negative charge. These partial charges are the cause of hydrogen bonds between water molecules. Ionic bonds. Ions are formed when two atoms differ in electronegativity so much that the more electronegative atom steals an electron from its partner completely. One atom has gained an electron and one atom has lost an electron, resulting in two oppositely charged atoms or molecules that are attracted to each other. A positively charged ion attracts a negatively charged ion, forming an ionic bond. Any two ions of opposite charge can attract each other and form an ionic bond. Bonds with different strengths. Covalent bonds and ionic bonds are two types of strong chemical bonds, but weak chemical bonds also play a role in life. While individually weak, when many occur at the same time, weak chemical bonds can become very powerful. Hydrogen bonds. Hydrogen bonds are formed between a hydrogen atom with a partial positive charge and a partially negatively charged atom. A hydrogen atom may have a partial positive charge because it is covalently bonded to a more electronegative atom, and the partially negatively charged atom acquires its partial negative charge by covalently bonding with a less electronegative atom. The attraction between the partially positive hydrogen and the partially negative atom is called a hydrogen bond. Hydrogen bonds give water its unique properties, such as adhesion, cohesion, and water being less dense in its solid form. Van der Waals interactions. Electrons are constantly moving in all directions within their electron shell. In molecules with nonpolar covalent bonds, electrons may accumulate by chance in one part of a molecule, resulting in a negatively charged region where the electrons build up, and a positively charged region where the electrons left from. The constantly changing regions of positive and negative charge allow atoms or molecules to stick to each other. The end.